دقائق
لكل اللي بيتابعونا.
دقائق مازن، انا اللي ببدا.
اوكي تمام.
طيب، بسم الله الرحمن الرحيم. انور فتح الرحمن احمد ضفع الله، مجموعه الباحثين السودانيين. وصلت للسلسله بتاع السيمينارات بتاعتنا على الانترنت، الويب سيمينارز، الويبينارز. الهاشتاج اللي بنستخدمه اللي هو هاشتاج SRF_webinar، هاشتاج SRI_webinar. عندنا انه الليله معانا واحد من الشباب، واحد من انصع الشباب بتوع السودان، اللي انا صراحه اتشرفت كثير جدا بانه اتعرف عليهم في 2008 لما كان جايين عبر البروتوكول بتاع التعاون ما بين كوريا الجنوبيه ودوله السودان، تكريما للخمسه الاوائل بتوع الشهاده السودانيه، لهم فرصه بتاعت تمشوا زياره لكوريا الجنوبيه، والوقت ده كان طالب دكتوراه. فتشرفت بلقاء 5 شباب رائعين جدا جدا. كان اولهم مازن عبد البديع AliKarar، هو شاب ريسيرشر و طموح ديسنت ودمث الاخلاق، وان شاء الله الليله حيكون معنا في ويبينار عباره عن رساله الماجستير بتاعته بعنوان Scheduling Internet of Things Request to Minimize Latency in Fog Computing. مازن حيستلم المقالة بتاعت الامور وحيعرفكم بنفسه، وبعدين حيبدا الويبينار بتاعه. اتفضل يا باشمهندس مازن.
طيب، شكرا جزيلا دكتور انور. بسم الله الرحمن الرحيم. السلام عليكم لكل اللي بيتابعونا. اول شيء نقول لكم كل سنه وانتم طيبين، وتقبل السودانيه سنه 2008 من مدرسه الشيخ يوسف الدقال في ام درمان، والحمد لله كنت اول الشهاده السودانيه بفضل من الله ومنا. نسبتي كانت 96.9 ودي فرصه كويسه برضه الواحد يهني ممتحنين الشهاده السودانيه، لان النتيجه بتاعتهم كانت طلعت قبل يومين. نقول لهم الف مبروك، واتمنى لهم حياه عمليه ودراسيه ناجحه ان شاء الله. من الثانوي دخلت جامعه الخرطوم الالكترونيه، وتخصصت في الالكترونكس اند كمبيوتر سيستمز. تمام. اتخرجت في سنه 2013. اول ما تخرجت اشتغلت في شركه سودانيه R&D سنتر لمده سنه ونص. بعدين غادرت البلاد، غادرت السودان، جيت هنا الامارات. لقيت منحه دراسيه كامله مدفوعه التكاليف في الجامعه الامريكيه في الشارقه لدراسه الماجستير لمده 2 سنين. والحمد لله هسه تقريبا شبه خلصت الماجستير بتاعي. عملت المناقشه بتاعت البحث قبل اسبوعين، وسعيد جدا انه اقدم لكم البحث بتاعي في مؤسسه الباحثين السودانيين. ان شاء الله هنقدم لكم البحث ياسر، وان شاء الله اذا في زون انترستد في المجال بتاعنا بتاع الفوق كومبيوتنج والكلاود كومبيوتنج والاي او تي، سعيدين جدا بانه يراسلنا، ونحن ان شاء الله يعني سعيدين انه نساعدهم بكل ما استطعنا. فان شاء الله هقدم لكم البرزنتيشن باللغه الانجليزيه، لانه شويه الكلام يعني اغلب المصطلحات باللغه الانجليزيه، فما ينفع كلام نص عربي ونص انجليزي. let's start, let's do it. طيب دكتور انور، كيف الوضع عندك؟ فول سكرين؟ هلو؟
لسه ما فول سكرين يا مازن. حاول ثاني، اعمل شير السكرين. ايوه كده فول سكرين.
طيب كده كيف الوضع؟
تمام فول سكرين. جو اهيد.
تمام. طيب يلا بسم الله. Thank you so much, Dr. Anwar Dafallah, for giving me the opportunity to present my master thesis in the Sudanese Researchers Foundation, and it's actually my pleasure to be involved in such platform with you guys. So today I'll be presenting my master thesis, my master research work, titled Scheduling IT Requests to Minimize Latency in Fog Computing. As you can see, this title has many keywords, but to explain it right now at this point, however, I'm going to take you through these terms and keywords as I'm doing this presentation. Okay. So first of all, I'll start by a brief introduction about IoT, Internet of Things, what it is. IoT is a novel paradigm that is gaining a lot of attention within both the research and industrial environments. Okay, and especially these days in modern wireless telecommunications in countries such as UAE. Okay, and the basic idea about the Internet of Things is the widespread of a network that involves the everyday physical objects, things like the cars, the lamps, the ovens, the refrigerators, the washing machines. All these devices, all these physical devices will be provided with sensors, actuators, and software capabilities, hardware capabilities, in a way that make it able to send and receive data and interact with the physical environment around them without involving the human being in this process. So this is the core concept of IoT. As I said, we have these physical things. These things are provided with sensors and actuators. The sensors are used to sense, to collect the data, and then this data will be processed, analyzed, and then actions will be taken into the environment physically. And all this happens without involving the human being. It happens automatically. Okay, so this is IoT. And IoT applications in general have such characteristics. Number one, they demand real-time and critical latency requirements, because as I said, these physical devices, they interact with the physical world around them. They sense the data and they behave correspondingly in the environment. Let's take as an example, imagine that a power outage that happened in a smart city. And of course, this smart city will be provided with sensors, and then these sensors will be used to sense the power outage, for example, and then an action should be taken as fast as possible, otherwise disasters may happen. Okay. Number two, these IoT devices, these physical things, are very limited in terms of processing and energy and storage. Okay, and this way it may not allow any on-site processing inside these devices, and this way it creates reliability and performance issues. Okay, and IoT, Internet of Things, by definition, involves a large amount of information and data generation sources from a large number of IoT devices. All these devices will be generating large amount of structured and unstructured data. So data in different sizes and in different data types. So and this data will be generated in a very high frequency, and this is what's so-called big data. Okay, as you can see in this picture over here. So in order to address these challenges, many researchers have proposed having the integration between the IoT paradigm and the paradigm that's called cloud computing. As we know that cloud computing paradigm, we have these giant supercomputers on the internet, okay, and these supercomputers are very rich in terms of capabilities, and some researchers even say they are unlimited in terms of physical and virtual capabilities. So why don't we just take all these IoT devices, as you can see in this picture, and plug it into the cloud computing data centers? Okay, and cloud computing also is more mature technology than IoT, and most of the challenges that the researchers are facing now within IoT are mostly solved in cloud computing. However, the integration between IoT and cloud computing was beneficial, but it created many challenges. And I'm going to take you through these challenges. Number one, the large physical gap between the IoT devices that reside at the edge of the network and the cloud computing at the core of the network. As you can see in this picture, here we have the IoT devices and sensors, and then these devices will be connected to the cloud computing at the core of the network through the network gateways, switches, routers, and access points. So there is a large gap, and this consequently affects the real-time services and the latency sensitivity for the IoT applications. Okay. The second challenge is the growing number of IoT devices. Actually, Cisco estimated that by 2020, there will be 50 billion devices, actually more than 50 billion devices connected to the internet. All these devices and sensors will be generating huge traffic among the cloud computing data centers, and then it generates consequently significant bandwidth issues. Number three, it's not practical to transport large amount of data from these IoT devices into the core, into the cloud layer, because many IoT applications actually do not require the cloud scale capabilities. They might require only small scale capabilities, and we don't need the giants, the super capabilities that exist in the cloud. Number four, the huge operational cost of the cloud computing data centers. As I said, the integration between cloud and IoT will result in disturbing the cloud computing data centers with the IoT requests and services. And since this way, the cloud data centers should be fully up all the time. So for such challenges, many researchers have concluded that cloud is actually not sufficient to satisfy the critical and latency requirements for the IoT applications. Okay, and here's where a new paradigm called fog computing shows up. It's called fog computing or edge computing. Fog computing is a new model that invented by Cisco in 2012, and in fog computing, the edge of the network is transformed into distributed infrastructure by pulling or pushing the cloud resources from the core of the network towards the IoT devices at the edge of the network. And it's called fog since a cloud is actually fog is actually a cloud that is closer to the ground, closer to the edge of the network. And as you can see here, we have this kind of three-layered architecture. Okay, at the edge we have the IoT devices and sensors, the devices I talked about before. Then in the intermediate layer we have the fog computing devices. Okay, and at the core of the network we have the cloud computing data centers. And as I said, we are trying to push or pull these resources that exist at the core of the network towards the IoT devices where we need them over here. And then it creates this kind of three-layer architecture. So the integration between cloud and fog computing has many benefits. Number one, it reduces the latency. It reduces the latency, which is the key factor for IT applications, because the fog computing has its resources, as you can see over here, in physical proximity to the IoT devices. As you can see, these resources are actually closer physically to these IoT devices, and hence it reduces the service latency for the IoT applications. Number two, by using fog computing, a large number of requests and services can be served at the fog computing layer, and this way not all the data that's being generated by these IoT devices need to be sent to the cloud, to the core of the network, and this way we improve the bandwidth consumption. Also, fog computing directs the data to the optimal place for processing. Okay, how the sensitive requests and services will be served at the fog, because this is actually closer to the IoT devices, and the long-term analysis will be sent to the cloud computing data centers. And this way also, the fourth benefit of integrating fog and cloud, the cloud computing data centers will be relieved significantly. Why? As I mentioned before, large portion of the IoT requests and services will be served at the fog computing layer. Okay, so right here I have this small video, and I hope it's going to work properly, and it might help me in explaining the idea of fog computing. So let me just play this video. Anwar, can you hear me? Hello? Dr. Anwar? Doctor, I just have a small problem playing a video because I have a video embedded in the slides.
You can run it from your own computer and share screen.
Okay,
leave the presentation right now.
I'll do that. So I have it downloaded over here.
Okay.
So downloads and video. Yeah, there it is.
And then you choose from the application view.
Okay. Dr. Anwar?
Yes?
Can you hear the voice, please?
No.
Even more value
now?
Created.
Now?
I hear the voice, however, I cannot see the video.
Okay, just 1 second. Let me share the screen.
It's referred to as the Internet of Things, or IoT.
Okay, we go over here, screen share, application window. So, can you see it now, Doctor?
Yes, I can see it.
So let's just listen to this video.
Okay.
In the future, various information and things will be connected to networks, and we expect it will be. People can now live more convenient and comfortable lives. And with things coordinated together and coordinated with information, it's expected that even more value will be created. At NTT, we're always leading this field, and by staying one step ahead, we will usher in a future that provides new value for everyone. When various information and things are connected to networks, it's referred to as the Internet of Things, or IoT. And huge, varied, and incomplete data generated by IoT need to be processed and responded to in a very short time. Today, the cloud has become an indispensable part of that process. However, the cloud that's been centrally deployed on a global scale needs to process an enormous amount of data. In addition, as the physical distance between the user and the cloud increases, transmission latency increases with it, increasing response time and stressing out the user. On top of that, the processing speed in this environment is largely dependent on the performance of the user's device. The solution to these problems is the edge computing platform. The edge computing platform works by allowing some application processing to be performed by a small edge server positioned between the cloud and user, and crucially in a location physically closer to the user. This allows for some of the workload to be offloaded from the cloud or user's device at a location closer to the user for processing, while speeding up applications that require a low latency response. A good example of an application is a web browser.
So I'm gonna stop it right here. So Doctor, I'm gonna go back to my slides. Give me just 1 second.
Okay. Okay.
Okay. So
Yes, right.
So yeah, the video I've showed you guys, it's actually one of the most excellent videos in explaining the integration between IoT, fog, and cloud, because it succeeded in explaining the idea that the cloud resources actually they reside far from the edge of the network, from these IoT devices. And since we have this fog computing resources, they sit in physical proximity to the IoT devices, and then it can benefit these devices in terms of the service latency. Okay, so the integration between fog and cloud and IoT results in such three-layered architecture. As you can see here in this picture, we have the IoT requests for the services will be coming from the devices, from the edge of the network, and then these requests should be served or processed in in the resources that exist in these two different layers. We have the resources, some resources sitting in the cloud layer, and some other resources sitting in the fog layer. So, and here I'm just going to mention a quick thing that the fog computing, although it's a small scale from the cloud computing resources, but as I said, it's closer to the IoT devices, and this is actually the strong advantage about the fog computing paradigm. Although it's very light, it's not as rich as the cloud resources. However, it benefits the IoT requests and services in terms of the service latency. So the research questions that might pop up in this in such a paradigm is that, where do we send these requests, to the fog or the cloud? Okay, and how do we schedule these requests? So it's an issue of scheduling. How do we allocate these requests, and in what order should we execute these requests? Okay, and is there any way to minimize the service latency, which is our key research question? Okay, and can we meet the deadlines of these requests if these IoT requests have deadline requirements? They need to be executed in such amount of time, and also these IoT requests might ask for physical capabilities in terms of computational power, I mean CPU, in terms of storage, in terms of networking. So all these requirements for these IoT requests should be satisfied. So we are approaching these research questions, okay, as you can see here, as a scheduling problem. And then right now I'm going to explain what do we mean exactly by scheduling problem. So a scheduling problem is generally defined as the allocation of tasks to capable resources at a specific time. As you can see in this picture, we have a pool of tasks from 1 up to m, and then we have these resources from 1 up to n. And then these tasks should be allocated into these resources so that they can get the service. And at this point, actually, like these tasks should be allocated in the resource at a specific time. This is a key term when it comes to the scheduling. Okay, and most of the scheduling problem have 4 basic elements. We have the resources, as I said before. We have the tasks, as you can see here. We have objectives. Objectives are they are objectives in the scheduling problem that need to be fulfilled. Okay, and the 4th element are the constraints. For example, if there are any type of constraints that have to be met within the scheduling problem. Like, for example, over here, we can put a constraint that a task should be executed in only 1 resource. So that's just a simple example of having the constraints within the scheduling problem. And since most of these scheduling problems have objectives that needs to be fulfilled, as you can see, typically optimization concepts are involved when it comes to scheduling. We could have objectives. The objective for the scheduling problem could be things like minimizing the service latency, which is exactly our case. Okay, it could be also maximizing the resources utilization. We also want to allocate these tasks into these resources in a way that we can maximize the resource utilization. The objective could also be things like minimizing the bandwidth consumption, minimizing the power consumption. So these are typical objectives that are involved in the scheduling problems. Okay, and in general, also, in order to solve a scheduling problem in an optimized way, in case we have an objective that we want to maximize or minimize, there are 2 broad categories of methods. Okay, we have the exact methods and we have the heuristic methods. The exact methods or the exact algorithms are the algorithms that can find the absolute optimal solution to the scheduling problem. They can find the one maximum or minimum solution. Okay, these algorithms include the simplex and branch and bound. On the other side, we have the heuristic methods. The heuristic methods are the algorithms that can find a solution that has some degree of optimality. However, the absolute optimal solution, the one optimal solution, the maximum or the minimum solution is not guaranteed. But the advantage of having the heuristic methods are they can find these heuristic solutions in a reasonable computational and execution time. they take typically much less execution time to come up with these solutions. Heuristic methods, examples for these heuristic methods include simulated annealing and ant colony algorithms, genetic algorithms, and an algorithm called particle swarm optimization. Okay, so the problem definition of our research is that we are trying to build a high-level scheduler, okay, for the paradigm of integration between IoT, fog, and cloud computing. The three-layer architecture I showed you before. This scheduler will be receiving the IoT requests, okay, and then it should allocate these requests and schedule these requests into the resources that exist at the fog and the cloud, considering the characteristics of both the fog and cloud resources. Okay, is that the fog, it's small scale, but it's closer to the network. The cloud resources are rich, but they are far from the IoT devices. While in the same time, minimizing the service latency, which is the key factor in what we are trying to do. Okay, we are trying to minimize the service latency for these IoT services and applications. And also, we have to meet the physical capabilities, as I mentioned before, and the deadline requirements in case these IoT requests have critical deadline requirements. They have to be met also. So in terms of modeling the three-layer architecture, as I mentioned, we have the edge layer, the fog layer, and the cloud computing layer. In the edge layer, we have the IoT devices or the edge devices. These edge devices will be generating the requests for the service. Okay, so these requests should actually travel to the resources that exist at the fog and the cloud layer. Okay, but before entering these two layers, all these requests will be received at a scheduler. So this scheduler is the one who decides whether to push these requests into the fog resources in the fog layer or the cloud resources in the cloud layer. Considering what? Considering the attributes of these requests. The attributes of these requests could be things like the size, the time the request gets initiated, the priority, and the deadline requirements, and the physical capabilities, as I mentioned before. And also the scheduler takes into consideration the attributes of these resources in terms of capabilities, in terms of processing speed, in terms of like how far these resources are closer to the IoT devices. Okay, as you can see here, the fog devices are closer, and the cloud resources are far. So the objective, as I mentioned before, is to minimize the service latency. Okay, the definition for this service latency is that it's the round-trip time from the moment the request gets initiated at the edge of the network to the moment this request reaches the resource, whether in fog layer or cloud layer, gets served, and then the results should be sent back to the requester or the IoT device requesting for the service. So this round-trip time, we call it service latency, and this is what exactly we're trying to minimize in order to serve these IoT applications at the edge of the network. And so in order to calculate the service latency, these are the delay components or the time components we are considering in our modeling to the problem. So the first component is the transmission delay. Okay, the transmission delay, all these are kind of networking concepts. Okay, so the transmission delay is the time it takes to push the request packets into the link, because as I mentioned, these devices, the IoT devices at the edge of the network, the fog devices and the cloud devices, they reside in different networking layers. So these requests should be pushed into the link, into the network, in order to reach the resource. So we had the first component, the transmission delay. Number two, we have the queuing and networking delay. The queuing delay, this is the time the request packets takes into passing through the network gateways, routers, and switches. Okay, so we are considering this delay component also. The third component is the processing time. The processing time, this is the actual processing time of these requests inside the resources in fog and cloud layer. So the actual processing time, that should be taken into consideration also. We have also dependency constraints. Okay, The dependency constraints affects the service latency in a sense of we might have requests. For example, this request depend on a second request. So this means what? The second request, since it depends on the first one, it cannot start executing unless the first one gets executed and finish the processing completely. So that's an extra delay component that have to be considered within IoT applications. The last component is the resources queues, because in our modeling we are considering that each resource can process only one request at a time. So when these requests are sent to these resources, they will be waiting in queues within these resources. So that's also a time component that should be considered. Okay. So in terms of applications and scenarios, there are many application scenarios that can be implemented, benefiting from the integration between IoT, fog, and cloud. However, here I'm just mentioning two application scenarios. The first one is the connected vehicles. In the connected vehicles, we have, as you can see in this picture, all the cars and vehicles are connected to each other through internet. And then these cars will also be connected to the smart traffic lights. These smart traffic lights are actually fog computing nodes. And as I mentioned, the fog computing nodes are sitting as much as close to the IoT devices, which are the cars in this case. These fog computing nodes, the smart traffic lights, will be embedded with sensors to sense objects like whether we have pedestrians around the cross area, whether we have cars. And also these sensors can sense stuff like if there is any approaching car that is approaching the crossroad in a very fast speed, then the fog computing node, which is the smart traffic light, should respond very quickly so that it can prevent any disaster or any accident from happening. Okay, so this is one application. The second application is the smart grid. As we know, in smart grid, we are trying to provide the electricity services through internet. So all the consumption stations or appliances will be connected to the internet. And then we can, for example, put a fog computing node over here, and we connect all these consumption stations and appliances to this fog computing node. And then this fog computing node, using sensors, it can sense stuff like the power outage, if there is any power outage that's happening somewhere, and if there is also any kind of an overload, consumption overload. And then having the fog computing node in closer proximity to these stations and consumption appliances, it can respond very fast. For example, if there's a power outage, it can add a stand-up power station. If there is an overload that's happening, it can add an extra standby power sources, for example. So these are just examples of the rich applications and scenarios that can be created from the integration between cloud, fog, and IoT. Okay, that's all I have for you guys. Thank you so much. Thank you so much, Dr. Anwar. Dr. Anwar, I'm done with the presentation.
Thank you very much for the presentation. Thank you. Then you can switch back. Okay, now I see you. شكرا جزيلا باشمهندس مازن على التقديم.
شكرا دكتور.
جدا للديزرتيشن بتاعك بتاع الماجستير. الحقيقه كان الاسئله بتاعتي كلها بتدور حول الابلكيشنز، لانه اي كونسبت ولا بارادايم بيتقدم في مجال التكنولوجي بصوره عامه لازم يكون عنده feasible applications that people can relate to.
طبعا.
بتاعي انت قدمت تقريبا سيناريوز للاستخدام بتاع التكنولوجي دي.
طبعا.
طيب انت شايف how far are we في الريسيرش في السودان، انترنت اوف ثينجز والكلاود والفوج؟
طيب بالنسبه للابلكيشنز عموما اللي ممكن تتبني من استعمال الفوج كومبيوتنج والكلاود كومبيوتنج، طبعا في unlimited unlimited افكار و unlimited applications ممكن تتبني. حتى نحن في الريسيرش بتاعنا يعني ما حاولنا نعمل implementation لاي حاجه، لانه بجد يعني القصه يعني شويه مكلفه، من حيث انه الواحد المفروض يعني يبني applications from scratch، يعني من sensors لاكشويترز، والفكره ذاتها المفروض تكون very rich بحيث انها تخدم غرض معين. نحن الريسيرش بتاعنا كان بس يعني we're just try to prove that انه the fog computing is a must when it comes to IoT applications and services، لانه بيساعد كثير في حته السيرفيس latency دي، لانه الكلاود زي ما عارفين انه هو بعيد من الادج بتاع النتورك وكده. فبس دي الفكره بتاعت الريسيرش، نحن يعني بنحاول نثبت جدول الفوق كومبيوتنج في الاي تي ابلكيشنز.
كده
دكتور انور؟
ايوه معاك سامعك. قلت لك هل عملتوا اي publications؟ did you publish any papers out of this research؟
نحن لحد الان ما عملنا publication، لكن كتبنا جورنال وجورنال بيبر، واكشلي سلمناه كان قبل شهرين، يعني within as an IoT implementation عديل، كان عملناه في واحده من البروجكتس اشتغلناها في الجامعه، بس لسه يعني الجورنال بيبر اون بروسيس. شغالين على جورنال بيبر ثانيه بالنسبه للريسيرش ورك بتاع الماستر ثيسيس، اللي هو نفس الشغل اللي عرضته عليكم ده، بس لسه الجورنال بيبر ما خلصت يعني.
تمام ممتاز. طيب انت مازن لقيت فرصه بتاعت انك تعمل ماسترز في الجامعه الامريكيه في الشارقه.
طيب.
لو انا هسي شاب سوداني هسي دي يعني خلاص في نهايه المعيه بتاعتي، معظم الجروب بتاع الباحثين السودانيين الناس بتسال عن المنح الدراسيه. نفس الباث بتاعك داير القى نفس الطريق بتاعك على اساس انه اعمل بيه ماستر، فالطريق بتاعك شنو؟ كيف وصلت للحته اللي انت فيها الان؟
والله بالنسبه للمنحه بتاعتنا دي، نحن المنحه بتاعت الجامعه الامريكيه في الشارقه هي بتجي من داخل الجامعه نفسها، يعني ما في مؤسسه الواحد مثلا بيقدم لها في السودان ولا كده بحيث انه يتحصل على المنحه. راسلنا الجامعه اونلاين، تمام، رسلنا كل الدوكيومنتس بتاعنا، كل الكواليفيكيشنز بتاعتنا، وتحصلنا على المنحه من داخل الجامعه، من داخل الديبارتمنت. وحقيقه يعني بالذات هسه يعني انه بعد ما نحن خلصنا الماستر بتاعنا اتفتحت فرص كثيره منح دراسيه حتى في الديبارتمنت بتاعنا بتاع الكمبيوتر انجينيرنج في الجامعه الامريكيه. فانا من هنا بناشد كل الطلاب في السودان، يعني اي واحد لو عايز يقدم يعني just go ahead، تلقى كل المعلومات موجوده في الويب سايت بتاع الجامعه الامريكيه aus.edu. وحتى البروسيس ذاتها ما بتاخذ زمن طويل، يعني بتاخذ حوالي 2-3 شهور لحد ما الواحد يعمل ترانسفير كامل، يعني لحد ما يجي الجامعه هنا ويبدا الماستر بتاعه. فالفرص متواجده، انا بشجع الناس انه يقدموا اونلاين.
تمام. طيب انت عرفت بالموضوع كيف اصلا يا مازن؟
والله هو طبعا القصه دي بتبدا بنتورك. نحن عندنا شباب جو الجامعه قبل ما نجي نحن، يعني عندنا تقريبا 2 من زملائنا او 3 من زملائنا جو نفس الجامعه قبل ما نجي نحن. فهي يعني الناس بتشير المعلومات، بتتعرف يعني عن طريق النتورك بتاعنا نحن كطلاب من جامعه الخرطوم يعني.
ايوه. طيب لو ما انا ما من جامعه الخرطوم هعمل شنو؟
والله يا اخي يعني الواحد بس اهم شيء طبعا يكون مواصل، يكون عندي نتوركينج بصوره كويسه مع الناس. عرفت كيف؟ لانه يعني الناس ما بتساعد بعض، يعني مثلا انا شفت فرص بقدر استفيد منها انا وبشيرها مع اصحابي على انه لو في زول عايز يقدم ولا كده، فالناس بتتشارك كل المعلومات دي. وزي ما قلت لك الواحد يحاول دائما يبني نتورك كويس، يعني يشوف الناس اللي قبليه والسناير، الناس اللي قبليه مشوا وين وقدموا وين، بحيث انه يكون شايف وعارف يعني.
طيب دي حاجه اساسيه من الحياه اللي احنا بنحاول نبني نتورك تكون يعني زي ما يقولوا متنوعه من الناس في مختلف الجامعات، وحتى السودانيين اللي قروا برا السودان والناس اللي قاعدين برا السودان حاليا، بحيث انه يكون في طريقه بتاع الترابط، التبادل بتاع معلومات ولا كده. انا بعرف انه يعني النتورك بتاع جامعه الخرطوم الشباب الخريجين والكده والبتاع قويه، الناس بيقدروا يعرفوا الجروبات بتاعتهم كده. لكن اي
طيب.
زول برا النتورك ده في مجالات كثيره الناس بتكون في زول مؤهل للفرصه لكن ما عارف انها موجوده هناك. فشكرا جزيلا لتاسيس السيمينار بتاعك ده. الناس تعرف انه والله في فرص بتاعت ماسترز في الجامعه الامريكيه. طيب انا بدي اخذ برضه سؤال ثاني، بما انك انت كنت اول الشهاده السودانيه في سنه 96 في سنه 2008. 96 دي طبعا سنتنا
2008 2008 دكتور.
هاي. فداير اعرف انتوا يعني شنو الحاجات اللي استفدتوا منها كونكم انه والله كنتوا المتميزين والمتفوقين وكده من المجتمع بتاع الجامعه، من المجتمع بتاع السوداني ات لارج، يعني افادكم بشنو؟ قدم لكم شنو؟ لو في حاجه ما قدمها لكم والمفروض انه تقدم لكم، الناس الثانيين الاسي ديل الاوائل موجودين هسه. اعتقد انه عندكم مجموعه برضه اسمها ملتقى الطلاب المتفوقين، مش كده؟
ايوه تمام، ملتقى الطلاب المتفوقين. والله هو شوف، هو طبعا يعني الواحد يعني كونه اول حاجه كان من ال100 الاوائل، وبعد ذاك يعني تخرجنا من الثانويه دخلنا جامعه الخرطوم. فالحاجه دي يعني اكثر ما بتفيد من ناحيه environment، لانه زي ما قلت لك يعني مثلا نحن يعني الشباب بتاعين 2008 ديل ما اول ناس نتحرك تجاه الحاجه دي، انه الواحد عايز يسافر برا وعايز يلقى منحه دراسيه برا السودان، عرفتها. فالناس من قبلينا كتار كانوا بيتحركوا يعني، وكانوا بيفتشوا ويشوفوا الفرص المتاحه وين. فبجد يعني الناس بتنور بعض، الناس بتفيد بعض. وانا ما اعرف يعني لو كان مثلا ما خشيت في environment زي دي، يعني شويه يعني معلومات بتكون ضعيفه. عرفت كيف؟
ايوه، يعني هسه لو ما في ملتقى الطلاب، لو في ملتقى الطلاب المتفوقين حقدر اعرف انه والله في منح دراسيه مثلا في الجامعه الامريكيه في الشارقه او في غيرها في حتات ثانيه.
طيب.
هل المنح والتبادل بتاع المعلومات الموجود داخل الجروب بتاع ملتقى الطلاب المتفوقين ده، بما فيه مثلا لو في الجامعات السودانيه ولا التعليم العالي السوداني والبتاع، هل ده كل الموجود، ده كل المتاح؟ يعني هل في حاجات غايبه عنكم برضو؟ انتوا برضو موجودين في الجروب ده وفي حاجات غايبه عنكم، ولا دي
هو
كلها
اكيد
انتوا بتلقوا
طبعا.
اي حاجه موجوده؟
لا اكيد طبعا. يعني هاي نحن بنحاول يعني نشوف اقصى ما بنقدر عليه يعني انا ما اعرف يعني تقريبا يعني هو يعني الشباب اللي حوالينا ديل يعني عارفين المنح الموجوده في اليابان، المنح الموجوده في الصين، المنح الموجوده في يوكي، المنح الموجوده في امريكا. عرفت كيف؟ لكن انا متاكد تماما انه يعني دي ما كل الفرص المتاحه يعني. والستيل الواحد بعد ده زياده على ده كله لو مشى فتش براو واجتهد براو قد يلاقي فرص ثانيه. عرفت كيف؟
نعم.
آه.
طيب بالنسبه لكم، بالنسبه ليك انت هسه دي اتخرجت من الماجستير، في خطوه ثانيه في حياتك عايز تمشيها، سواء كان في اتجاه بتاع ريسيرش ولا اكاديميك ولا بروفيشنال لايف ولا كده. بتلقى منتورنج، بتلقى في زول بيرشدك بيوريك الدرب بوين. انتوا ما شاء الله الناس عندكم زي يقولوا برين باور كبيره جدا جدا. البلد نفسها قاعد تستفيد منكم كيف؟ يعني ده السؤال طوالي بيطرحوه الناس، يقول لك يا اخي الشهاده السودانيه دي وين؟ البلد دي ليه ما ماشيه قدام الى اخره؟ ده اذا كان الناس قررت انه والله احنا حنمشي في الصوره بتاعت احسن او اشطر ناس عندنا، ما داير نمشي بالافريج بتاع كل الناس. تقريبا هم اللي عملوا لنا الحياه الكويسه، نوفر لهم المواد اللي قاعدين نسوي لهم الى اخره. هل انت اسي دي شايف انه والله في ناس ماسكين بيدك كده قاعد يودوك لقدام، ولا انت الطريق برا؟
والله يا دكتور انور بصراحه والشينا تتقال يعني بجد. يعني نحن اللي بنعمل فيه ده كله يعني هو اجتهاد، وهو مش اجتهاد يعني هو اكشلي تخبط. عرفت كيف؟ يعني نحن بنحاول باقصى ما عندنا. عرفت؟ بنحاول نستشير، بنحاول دائما نسال الناس اللي قدامنا. لكن فعلا بصراحه يعني يعني ما في جهه كده مثلا مسؤوله من الاكاديمكس عموما يعني، والاكاديميك اكتيفيتيز دي بحيث انها مثلا تنور لنا الدرب بتاعنا. عرفت كيف؟ فكله يعني اجتهادات انديفيدوالي زي ما بقولوا بصراحه كده يعني.
اجتهادات فرديه.
اجتهادات
تمام،
فرديه.
كلام جميل جدا. وحتى الاريا بتاعت الريسيرش نفسها بتختار انت براك، يعني ما في زول بيقول لك انه والله السودان مثلا في ال 10 وال 15 ولا 20 سنه الجايه محتاج في المجالات الفلانيه استراتيجيكلي. لو انت داير تكون في صناعه القرار ولا الشيفت بتاع التكنولوجي في البلد ولا بتاع، امشي اقرا في الحاجه دي. ما في زول بيقول لك كلام زي ده.
صح، هاي للاسف والله، يعني للاسف.
اوكي تمام. وطبعا دي مشكله بتاعت ليدرشيب وبتاعت مانجمنت يعني في البلد كلها، في البلد ككل. واحنا ان شاء الله بنحاول نساعد عبر انه الناس تعمل لها جروبس بتاعت كولابريشن ما بين جونيور والسينيورز. نحن عندنا في ناس بيقدم والله شويه اسمه شنو ده، شويه نصائح ومنتورنج للطلاب والباحثين، لكن تظل هي 1 تو 1. لحد الان ما عندنا جروب كولابريشن، لحد هسه دي ما في. تقول المجموعه البحثيه دي بتعمل في الحاجه الفلانيه وعندها البادجت الفلانيه، لحد هسه دي كل الحاجات موزعه.
صح. هاي
ان شاء الله حنحاول نعمل الكلام ده، وطبعا بجهودكم انتم بافكاركم وبالطاقات بتاعتكم.
ان شاء الله والله يا دكتور، اذا احتاجتوا اي مساعده مننا فاحنا we're up for helping يعني.
ان شاء الله ان شاء الله. باشمهندس مازن، والله انا اقول لك شنو صراحه الكلام معك ما بيخلص، يعني الواحد سعيد جدا انه يشوفك مره ثانيه اونلاين.
والله.
ان شاء الله انه الشباب انترستد في الكلاود كومبيوتنج، في الانترنت اوف ثينجز، في الفوق، كلهم يعني يكونوا استفادوا من الموضوع ده ويتواصلوا معك بعد السيمينار ان شاء الله.
يعني بجد اذا في اي زول انترستد،
شكرا لك وان شاء الله في ميزان.
اذا في اي زول انترستد في الحته بتاعت الكلاود كومبيوتنج والفوق كومبيوتنج والابلكيشنز بتاعت الاي او تي والموديلنج بتاع الحاجات دي، يعني يو كان ريتش مي اوت، وانا بقدر بساعد يعني ان شاء الله بكل اللي عندي. تمام، شكرا جزيلا دكتور انور، دفع الله فور هافينج مي.
شكرا جزيلا.
نتلاقى
ان شاء الله
نتلاقى مره ثانيه ان شاء الله. شكرا دكتور، يلا السلام عليكم.
مع السلامه.
وانت طيب دكتور، مع السلامه.